Hello, and thank you very much for your interest in our research. My name is Kelly Estrada, and I am a master's student at Queen's University in the Wang Lefebvre lab, and we are assessing the potential of using mesocosms to facilitate the consumption of Cyanobacteria harmful algal blooms by the benthic snail Viviparous georgianus. Cyanobacteria are a group of prokaryotic microorganisms that can form large colonies on the surface of the water that look like green oil paint or thick scum. They do very well in eutrophicated, slow-moving, and warm bodies of water, and they produce their own energy by doing photosynthesis. A variety of cyanobacteria also produces cyanotoxins associated with various harmful effects on humans and other animals. The hero of our story is the benthic snail Viviparous georgianus. Viviparous georgianus is native to southern United States, but since the early 1900s has expanded its distribution to Canada. These snails live in high densities in eutrophicated lakes and are known for feeding on diatoms, green algae, and even fish eggs. Females Viviparous georgianus can live for 4 years, while males live for 3 years. Female snails give birth to fully developed individuals during the spring and summer months. There are several proposed solutions to address the cyanobacteria problem, but many of those solutions are expensive, short-term, and can have secondary effects. That is why we are proposing a new solution involving bioremediation. Bioremediation is the use of bacteria, plants, fungi, and yeast, and other organisms, like in our case a freshwater snail, to degrade or help control undesired pollutants. The purpose of our research is to break the physical barrier that exists between the floating cyanobacteria and the benthic snails by developing floating shallow mesocosms that will increase the snail's access to cyanobacteria. We want to assess if Viviparous georgianus is a good bioremediation tool to reduce the concentration of cyanobacteria from the water. We also want to know what conditions would maximize the snail's consumption of cyanobacteria. We collected the snails in the spring from Cranberry Lake and the bloom-forming cyanobacteria in the late summer from Dog Lake. These organisms were transported and kept under suitable conditions in the laboratory throughout the duration of the experiments. First, to find the appropriate amount of snails needed to reduce the cyanobacteria chlorophyllae from a high to a moderate concentration in 24 hours, we created a system where we could keep all conditions equal and only vary the snail's biomass, started at 10 grams per liter and then going up to 20, 50, 70, and 100 grams per liter. We compared the consumption of cyanobacteria among the different snail biomasses. Then, to find an appropriate depth of the platform where the snails could perform the best, we compared consumption among 5 different depths, 2, 4, 6, 8, and 10 centimeters. And finally, to know if the size of snails would have an impact in our systems, we separated the snails into 2 categories: large snails that weighed 3 grams or more, and small that were snails under 3 grams. And we compared the consumption of cyanobacteria between those 2 sizes. Chlorophyll was the measured variable that reflected the changes in cyanobacteria concentration. Our findings are: the minimum amount of snails needed to reduce the cyanobacteria chlorophyll concentration from high to moderate in 24 hours is 70 grams of snails per liter. Also, as the snail biomass increases, the consumption time decreases. No significant difference was found among different platform depths, and no significant difference was found among different snail sizes. To conclude, Viviparous georgianus does reduce the concentration of cyanobacteria chlorophyllae in relatively short periods of time under specific laboratory conditions, indicating the potential for its use as a bioremediation method for in situ studies. Within the range that we tested, depth doesn't seem to have a significant impact on the snail's consumption, nor do differences in snail size. Future research is required to test their effectiveness in the wild.